Hi guys, this is Ms. Agrovakis. We are going to be chatting about conjugate pairs and polynomial division today. So we're actually taking lesson 6, 7, and 8 and kind of merging it all into one in this lesson. So everything that you need to know, you've already learned for this lesson. It's just a matter of putting all the pieces together. And how do we apply everything that we've taught you in the last couple of lessons in one lesson? So one thing that we need to chat about first is just a reminder about what a conjugate pair is. So we have something like 2 plus 3i. Well, what's the pair to that? The pair to that is 2 minus 3i. So notice that the 2 stayed positive 2 and the 3i became a positive 3i and a negative 3i. So when we have a conjugate pair, the only thing that changes is the 3i and the negative 3i. So the thing that has the I. The other option, the other example would be if we looked at negative 1 minus root 7. What is the pair to that? It would be negative 1 plus root 7. So the only thing that changes is the root, the square root. There's going to be a positive and a negative version of the square root. So the negative 1 stayed the same. The only thing that changed was the root. The 2 stayed the same. The only thing that changed was the I. So these are the conjugate pairs that we have been talking about so far. And we'll be able to apply this in a few of our example problems today. So I want you to find all roots. Okay, this sounds super similar to lesson 6, right? Find all roots. You factored for me, you found all the roots, you used a little bit of knowledge from the quadratic unit with factoring and quadratic formula, etc., etc. So as we're working through this, now in this lesson, I give you the polynomial, I ask you to find all roots, but I'm going to give you one root. So looking at the leading degree is 3. This means that we are going to have 3 answers. At the end of this, you see the negative 3. The negative 3 is the one root that I am giving you. So if we're looking for 3 answers and I give you one answer, that means that you are responsible for finding the 2 other answers that we're missing. So how do we go about doing this? Well, if negative 3 is one of the roots, then we know that we have synthetic division as a tool, right? So negative 3 is one of the roots. That goes in our box. And then the coefficients of the polynomial above get set up in our synthetic division. All right, so now we work through our synthetic division. We drop the 1, multiply by negative 3. Add, multiply by negative 3. Add, multiply by negative 3. Getting a 0 is a good thing. If I give you the fact that negative 3 is an answer, you should get a remainder of 0. If you do not get a remainder of 0, then your math went wrong somewhere. So getting a remainder of 0 is what we will be looking for in this lesson. Remember, all these numbers went along with the terms up above. So this was the x cubed term, this was the x squared, this was the x, and then this was the number. So when we do the synthetic division, we're going to reduce our exponent by 1 every time. So we started with an x cubed, which means that this guy is going to be with the x squared, the x, and the number. So the quotient that we're looking at is this bottom row of numbers. The quotient would be 1x squared plus 2x minus 3. So then from here, we need to figure out what the other 2 answers are based off of the quotient. So this is going to happen every time. We're going to have to do some division with the given roots, and the quotient is what we are going to work with to find the other roots that we're missing. So when you're working through this, you have the option to either factor or use any other tool that you have used in the past. So right now, this is factorable. We could factor this into x minus 1, x plus 3. And if we check it, multiplies to negative 3, adds to positive 2, that works. So then the idea behind this is when we're solving it, it's equal to 0. So from this first factor, we end up with x equals 1. And from this second factor, we get x equals negative 3. So reporting our final answer, we want to state all of the roots of this polynomial. So over here, we got a 1 and a negative 3. But didn't we say that we're going to have 3 answers? Well, let's take a look back up here. Didn't I tell you I gave you one answer already, was negative 3? And then hold on a second. Negative 3 happened again. So what happens when roots happen more than once? Multiplicity. So negative 3 is going to have a mult 2 because it happened twice. One was given to you, and then you found the other one. And that's how you'd go about doing a problem like this. Okay. This one was pretty straightforward. Now what happens if I give you something like this one, where we have 3 plus 2i as one of your roots? Well, first and foremost, figure out how many answers you'll eventually have. So we know that we're going to have 4 answers total. So I gave you one already over here, but keep in mind we talked about conjugate pairs in the beginning, right? This guy is going to have a conjugate pair. So a conjugate pair would be 3 minus 2i. So we're looking for 4 answers. This now has given us 2. So we're only responsible for 2 other answers. So how are we going to work with 3 plus 2i, 3 minus 2i? Well, the last time we did synthetic division with the root I gave you. Now we can do synthetic with the conjugate pairs, but it gets very messy. So there's actually a way that we can do it with long division. The first thing that we need to do is dive back into lesson 7 where we expanded everything. So we need to take a look at x minus 3 plus 2i and x minus 3 minus 2i. And we need to expand this. So we had a shortcut to expand this last time. So the pattern that's happening here is it's actually a difference of squares. So what happens here is we can use this shortcut where we square x minus 3 and subtract 2i squared. And now we want to expand. So x minus 3 squared expands into x squared minus 6x plus 9. And then 2i squared ends up being 4i squared. Now what happens here is I squared is a value of negative 1. So then what happens is inside of here is a value of negative 4. So then after we add all this together, we end up getting x squared minus 6x. Then this is now a plus 9. And then this becomes a plus 4, which gives us a plus 13. What we've now spent the time doing is creating our divisor. This right here, this x squared minus 6x plus 13 is now the divisor of our division problem. So we're going to take a second and write the divisor as x squared minus 6x plus 13. And then our dividend is the original polynomial up here, this x to the 4th minus 11x cubed, etc., etc. So I'm going to take a second and write all that out. Okay, so here comes the long part of this process. So now we need to talk about the long division. So we want to figure out what multiplies to x squared to get it to look like x to the 4th. that would be x squared. Now multiply x squared by your divisor. So x squared times x squared is x to the fourth. X squared times negative 6x gets me negative 6x cubed. And then x squared times 13 gets me 13x squared. And then I subtract. And drop down the next terms. And repeat. What multiplies to x squared to make it look like negative 5x cubed? Negative 5x. Multiply the divisor and then subtract. All right, we've now done that step. So it looks like that we're going to have one last step. If we don't end up with a remainder of 0, we did something wrong because we originally were given an answer. We were given a root. So that means that we did something wrong in our process if we do not get a remainder of 0. So then we want to go back and check our subtraction. We want to check our pattern that we did back up here, difference of squares. Maybe there was an error there. But if you get a remainder of 0, that is a good thing. So the last thing that we want to do is one last time say, what do we multiply x squared by to make it look like 4x squared? Well, that's a positive 4. Multiply the divisor by 4 and then subtract. So it looks like when we do that, we get the same exact thing. So that means when we subtract, we get a remainder of 0, and that is a good sign. So now we want to work with our quotient. Our quotient, the answer to our division problem, is x squared minus 5x plus 4. So everything that you are going to work with is factorable. So if we want to take a second and think about what multiplies to positive 4 and adds to negative 5, that would be a negative 1 and a minus 4. So from that, again, this is setting it equal to 0. That's how we're getting our answers from this. We end up looking at x equals 1 from that factor, and x equals 4 from this factor. So our answers are 1, 4, and the 2 that we were given in the beginning, right? We were given 2. 1 was known, 1 we had to figure out. 3 plus 2i, 3 minus 2i. So final answer has to include those as well. So we have 3 plus or minus 2i for our final answers. All right, one more. So now I have one that has a root or a radical as a part of the answer. So this one, again, because it has a square root of 5, there's going to be a positive square root of 5 as well as a negative square root of 5. So we're going to have 2 minus square root of 5 to work with as well. And again, to reiterate, we're going to look for 4 answers. We already have 2. Yes. So that means we only have to do the work for 2 more. So we're going to expand first when we have this situation. So we have x minus 2 plus root 5 and x minus 2 minus root 5. We have that shortcut again where we have the difference of squares happening in here. So we're going to take x minus 2 and square it, and then subtract it with square root of 5 squared. So foiling x minus 2 squared out, we get x squared minus 4x plus 4. And then this one's a little bit easier than the i's. Square root of 5 squared is just 5. So that means the polynomial that comes out of this after we expand it is x squared minus 4x minus 1. And again, what we just found here would be the divisor. So now I'm going to set up my division, my long division, where x squared minus 4x minus 1 is my divisor, and x to the fourth minus 8x cubed, etc., is my dividend. So take a second and set that up. All right, and now we go through this with long division, just like we did before. So now we have, what do we do to make x squared look like x to the fourth? Multiply it by x squared. Take a second, multiply x squared by the divisor, and subtract. And repeat. What multiplies to x squared to get it to look like negative 4x cubed? Negative 4x. Multiply negative 4x by the divisor and subtract. And repeat once more because it looks like we have to at least go one more time. And what do we multiply x squared by to make it look like negative 5x squared? Well, that's negative 5. Multiply negative 5 to your divisor and then subtract. Those look the same, which is a good thing because if we subtract that, we end up getting a remainder of 0, which is what we were hoping for. So now we have to work with our quotient to factor that to get our final two answers. So we have a quotient of x squared minus 4x minus 5. So then this is factorable. This factors into x minus 5, x plus 1. What multiplies to negative 5 and adds to negative 4. So then again, we reiterate. We want to solve each of these. So we get x equals 5 from this one. And we get x equals negative 1 from this one. So then what are all our answers? We know we have 4 altogether. So we have a 5, a negative 1, and then didn't we have 2 in the beginning? We had a 2 plus root 5, and then we also knew that we had a 2 minus root 5. So that means that we have to tack that on to our final answer as well. And that's how you work through finding all roots given one root, even with conjugate pairs. So work on your homework. Let me know if you have any questions, and I'll see you in the next one.